Welcome to Look Learn Lead. Kindly subscribe and press the bell button for updates. Hello everyone, in this video we will be discussing about another category of access control protocol, that is the protocols for controlled access. There are three types: reservation, pooling and token passing. Before proceeding, please subscribe our channel so that you would get more updates and you can see more videos like this. Okay, let's see what are the controlled access protocols. Okay, the first is what is controlled access. Okay, what is controlled access is suppose we have two stations, and these two stations they would consult. Suppose we have two stations connected to a single link. Okay, that is, this link is shared between these two stations. Okay, in controlled access, these two stations have to take permission from each other. They has to take permission from each other. That is, if there are 5 stations in a row, and if there are 5 stations in the row, and if this station has to send, so this station has to be authorized by all other station. It has to take permission from all other station to transfer data in the shared link. That is controlled access. Okay, that is, a station consult one another to find which station has the right to send, and a station cannot send data unless it has been authorized by other stations. Okay, this is what is called controlled access. Earlier we see random access. In random access, okay, the station send randomly send data without consulting. They randomly send data. Okay, any station can send data. So in this we had carrier sends multiple access. Okay, so in this we had CD, collision avoidance and collision detection. Okay, this was random access. Okay, for controlled access, what is, each station must consult one another to find which station has to send, and a station cannot send if it has been not authorized by other stations. Okay, let's see what are they. There are three types of controlled access protocols. First is reservation. Okay, second is polling, and third is token passing. We will be seeing all of them. Token passing, we will be seeing all of them. Okay, let's see what is reservation. Okay, in reservation is, what is this, is a station need to make a reservation before sending data. So in the same way, before traveling on a train, we have to make some reservation. Okay, that is, the station has to reserve its reserve before it is sending data. Okay, and second is, the time is divided into intervals. Okay, see how it is. The time, suppose the time slot is divided into intervals. Suppose we will be dividing the time slot into 2 intervals. Let it be interval 1 and interval 2. Okay, in the first interval, if suppose we have 5 stations: station 1, station 2, station 3, station 4 and station 5. Okay, in the first interval, suppose station 1 and 2 want to send data. So there would be 2 data packets for station 1 and station 2, 1 and 2. Okay, this is the first interval. This is the second interval. In the first interval, if these two has to send data, so these two stations, that is station 1 and station 2, has to make reservations. See how. Okay, in each interval, a reservation frame precedes the data frame in that interval. Okay, how it is there? Suppose it is the first interval. In the first interval, there is data sent by station 1, data frame, and data frame sent by station 2. And these two stations has to make reservation. Okay, so what happens is, a reservation frame, it precedes the data frame. Now what is a reservation frame? This is how the reservation frame, this is a reservation frame for 5 stations. This is for station 1, station 2, station 3, station 4, station 5. Okay, there are 5 stations, and now station 1 and 2 want to send data. So what we would do is, station 1 want to send, so I would make it as 1. Station 2 want to send, then the reservation frame, we would set it as 1, and all else 0. What does this mean? That is, in this time interval, in the particular time interval, only 1 and 2 wants to send data, and these 3 doesn't. Okay, so let's have an example. Suppose this is the interval 1. It is the time interval 1. Okay, interval 1. In interval 1, station, suppose we have 5 stations in which station 1, station 3 and station 5 has to send data. Okay, so every data frame, the data frame precedes a reservation frame. Okay, in reservation frame, see, station 1, it is for 1, it is for station 2, it is for station 3, it is for station 4, station 5. 1, 3 and 4 has been marked as 1. Okay, this is the interval 1. It is in first interval, only these 3 stations were sending data. Okay, let's see the interval 2. This is interval 2. In interval 2, only station 4 is sending the data. So what would be our frame? What is 1, 2, 3, 4, 1, 2, 3, 4, 5? We're dividing it in 5. Only station 4 I'll mark it as 1, other all the else would be 0. Okay, it is like 1, 2, it should be 3. Okay, only station 3 would be sending, in the station 3 would be sending, and all the else is 0. Okay, is it clear? Let's move on to the next one, that is polling. Okay, now what is polling? Polling, it works with topologies. Okay, one divide is in polling. Suppose we have five stations. 5 stations in polling. Okay, in this, one station would be made being a primary station. One station is primary, and another 4 stations are secondary stations. Okay. So in polling, what we would do is, we would make one station as a primary station and all the others devices would be a secondary station. Okay. Suppose, and all data exchanges are made through primary station, even if the final destination is a secondary station. Okay. Let's see how it is done. Suppose we have 3 stations. Okay. Station 1, A and B. Okay. We have 3 stations. I had made station 1 the primary station, and station A and B are the secondary stations. Okay, suppose if station A want to send something to station B, so what it would be doing is, A would first send it to secondary primary station, and this primary station will then pass it to B. Okay, so any communication takes place through the primary station only. If a secondary station want to send data to another secondary station, then that secondary station must send that to the primary station, and the primary station would forward it to the destined secondary station. Okay, this is what is polling. In this way, we will be making of 2 functions. We would make using of 2 functions. One is poll and another is select. Okay, now when poll and select are used, let's see. Okay, select function from S, you can see when the primary station wants to send data. So then select would be used. When the primary station wants to receive data, then poll is used. Now let's see what is poll, select and poll. Okay, select is primary want to send. Poll is primary want to receive. Okay, let's see. Here we have 3 stations. PS is the primary stations. A and B are the secondary station. So we will be discussing select. What? Now suppose PS want to send data. So it has to check whether the channel is free or not. So it would send select to B. Okay. Then B would acknowledge, yes, I am ready to receive. PS want to send data to B. Okay. So it would send a select function to B. And B, if B want to receive, it would send an acknowledgement. Yes, I am free to receive. Then it would send data. Primary station would send data to secondary station and the acknowledgement would be there. Okay, this is how when the PS want to send, that is the primary station want to send data. If the primary station want to send data, first it would ask the secondary station if it want to send or not, if you want to receive or not. Okay, so by sending a select function, it can ask the primary secondary station whether it is willing to receive or not. Okay, if the secondary station is willing to receive, then it would send an acknowledgement. ACK is a positive acknowledgement, and primary station would just send data and acknowledgement is received. This is all about select. Okay, now let's see what is poll. In poll, we have PS this. Okay, in this what would do? The primary station want to receive data. So it would first send poll to A. That is, I am ready, I want to receive data. Okay. At this point of time, A sends a negative acknowledgement. That is, I have no data to send. Negative acknowledgement means A has no data, so no data to send. No data to send. Okay, send, then it would ask another station B. Okay, if you have any data to send, then send. B would send data and it would in turn see the acknowledgement. That is, polling is used, poll is used while receiving data and select is used while sending data. Okay, this is the polling second method, and the last one is token passing. Okay, now let's see what is token passing. In this, the networks are arranged in logical ring. Suppose the network is arranged in a ring, in the form of a ring. Okay, arranged in a form of a ring. It is unidirectional. It is not bidirectional. It is unidirectional. Okay, it is a form of a ring. Suppose this is the station. Okay, each station has a predecessor and a successor. Successor is the next station, predecessor is the previous station. For this station, this is the successor and this is the predecessor. Okay, this is the current station. Okay, for this, if this is the current station, this is the successor and this is the predecessor. Okay, each station has a successor as well as a predecessor. Okay, token is passed from the predecessor to the current station and current station to the successor. Now, what is token? Okay, there is a word. What is token? Token is a special packet. It is a special packet. Special packet. Okay, and the current station holds the token. Current station holds the token. Holds token. Okay, token is like a ticket. If you have a ticket, then only you can travel. Travel on the train. Now, what is a train here? Train is a channel. If you have a ticket, then you can travel on a train. And if you have a token, you can transfer your data on the channel. Okay, this is how it is. Okay. So what happens? Suppose there is a station S1. Okay, we have 4. Suppose I have 3 stations. Let us take example of 3 stations, S1, S2, S3. 4 stations, let us take, it would be easier to understand. We have 4 stations, okay, and this is like this. And suppose S4 has a token now. S4 is holding token. Okay, so now when S4 is holding the token, so S4 can send data on the channel. It has a control over the channel. Now, if S1 wants to send, then what? It has to wait. It has to wait for the token. Okay, it has to wait for the token. Then only it can send. Without the token, it cannot send data. Okay. Now what would happen? S4 after finishing data, after sending its data, it would pass on the token to its successor. Okay. If S3 wants to send data, if S3 has some data to send, it would send data by possessing the token. If it doesn't want to send data, it would pass the token to S1. Okay. Now S1 has the token with itself, so S1 can send the data. That is, the node which has the token, only that node can send data. Another nodes have to wait for the turn so that the token come to them. Okay. It is a sort of round robin. Okay, you can say it is like round robin. Okay. This was all about access control. This is controlled access. Thank you. Like, share and subscribe for more updates.